After knowing the resolving power of our eye or resolving power of an optical instruments or resolution limit, the distance between the slits to the wall can be considered as a Fresnel's distance, that can be considered as ZF, denoted with ZF. And after that, in earlier we discussed about diffraction and interference of light. The two concepts, the two phenomenon concepts are give the character of light, wave character of light, but no phenomena give an idea about is the light wave is a longitudinal or a transverse wave. In earlier 19th century, there is there is no any explanation about the wave nature of light. Either the nature of light will be longitudinal or a transverse. After Maxwell gave the electromagnetic theory, so that the electromagnetic waves are which is having the electric field, it can be formed electric and magnetic fields. Then that electric fields charges are randomly continuously changing at a point. The resultant electric field at a point changes randomly, means when the charges are changing continuously and randomly at any point, that can be considered as unpolarized light, means that can be moved to the all the distances, in different distances and with the different intensities. Each of intensity is having that I naught by 2. According to the nature of light, Maxwell gave an idea about by the electromagnetic theory. Electromagnetic waves are the transverse waves, means those are vibrating perpendicular to the direction of the propagation. So that in that polarization phenomena, he gave an idea about the transverse nature of light. Transverse nature of light means unpolarized light, means the light can be travel into the all directions. If we put on the light blow in all the directions, light can move to all the directions with the intensity of I naught by 2. In that means whenever the unpolarized light like this, that will move in all the directions. The light can be moved in all the directions, which is having that electric and magnetic fields. In all the directions, electric and magnetic fields. Whenever the unpolarized light incident on the polarizer, means when the electromagnetic vibrates along the one direction perpendicular to this, whenever they are moving from the slit, this is called polarizer. When it is rises, then the light will travel into the one direction only. The dots can be considered as magnetic and the arrows can be considered as electric field. Those are the perpendicular to the plane, means here this will be the polarized light. Polarized light. This is unpolarized, means unpolarized light. This will be the polarizer which the light can be transferred from the unpolarized to the polarized, means whenever the light is moving into the different directions, that can be transformed into the by sending to the in one perfect distance, one perfect direction, then that will be the polarization, the polarized light. That is polarized light. The phenomena which is involved during the transition or changing the electric and magnetic field lights into the in one direction, that can be the phenomenon is called as a polarization. That phenomenon is called as a polarization, means when an electric or magnetic vibrates only along one direction, perpendicular to the direction of propagation of the light. Light propagation is in this direction. Light propagating is in this direction. That vibrate perpendicular. That electric or magnetic fields are vibrating perpendicular here, perpendicular to the direction of propagation of the light, is said to be linearly polarized. That is linearly polarized, means a human eye can see like from this place. And unaided human eye cannot get the polarized light, polarized light directly. Unaided human eye. When we must, if we want to detect and polarize, we just need some of the aids, some of the instruments to get the polarized light. In the LCDs, in digital calculators, in digital watches, severally we are using this nowadays, the linearly polarization. Linear polarization. Frequently we are using linearly polarization. Linearly polarization concept is using in LCDs nowadays, calculators, digital calculators and digital watches, in all these terms. So that's why here unpolarized light means it is moving in all the directions, that can be transformed into when the light is moving in the same direction, means here that when the electric and magnetic charges vibrates only along one direction, perpendicular to the direction of light, perpendicular to the direction of propagation of light, is said to be linearly polarized. The phenomenon associated is called a polarization. It's called a polarization. The unpolarized light is incident on the polarizer. The emerging light, the light is emerged because of it, that is moving in all the directions, that light is emerged. So that here the emerging light becomes linearly polarized of each having the intensity of I naught by 2. Here that whenever the polarized light is traveling this is the plane IY, intensity of Y, and another is this one is IX. In that case we can see only in the direction of IY only, there is no any IX, means that is polarized, that is changed. For example, we are going on the road by bike in the several directions, in the different directions, because there is no any less of vehicles are there. Then if in case of there is some of the narrow way, when there is some of the narrow way, from the narrow way we can't go like whenever we free move in the wide range of way. So we have to move in the separate direction, in separate way, means that way is changed us into the some of the specific direction, means the narrow bridge is called as, here the light is traveling in all the directions, and here the polarizer, that polarizer changed the unpolarized light into polarized light, means that changed its direction with the intensity of I naught by 2 in the same direction, which is perpendicular to the direction of propagation of a wave. So that we can say that the light waves are transverse waves. The nature of light will be, wave nature of a light will be transverse wave nature. Transverse wave nature. In the diffraction and interference, there is no any given idea. The phenomenon did not give any idea about the nature of light. According to the polarization, give an idea that the light is a wave, the light nature is a transverse wave, that the charges or the particles are moving perpendicular to the direction of the propagation of the wave. We know that what is transverse wave and longitudinal wave. Longitudinal wave means the light will travels or sound will particles travels parallel to the direction of propagation of a wave. When the particles will move, the waves are moving perpendicular, the vibrations will happen perpendicular to the direction of the wave of propagation of a light wave, then that will be the transverse wave. So that's why we can say that light waves are transverse waves. Light waves are transverse waves. When the light is traveling, means a plane which passes through the direction of propagation of and perpendicular to the plane of vibration is known as a plane of polarization. Means the light is traveling from this IY and X through this plane. This plane means a plane which passes through the direction of propagation and perpendicular to the plane of vibration, perpendicular to the plane of vibration. Here is that, means here we can give an idea about this. This is Iy, this is Ix. This is the plane of polarization. That is the plane of polarization, means a plane which passes through direction of propagation and perpendicular to the plane of vibration is known as a plane of polarization. Means when the light is passes through the plane, means polarizing in some of the plane, that plane is called as a plane of polarization. Or the whenever the waves are vibrating, that vibrating plane is called as a plane of vibrating. Nowadays we are widely using that plane of polarization. After using the plane of vibration, nowadays we are using plane of polarization. Plane of polarization and plane of vibration, both are the same. So this is about a polarization definition and polarization. According to this, the polarization can be happen the reflection, refraction, scattering, like that. According to this, let's see what polarization by reflection means. So we know that whenever the light is incident on the some of the surface, if that is a transparent medium, then some of the light will refracted and some light will be reflected. Least amount of light reflected and most of the light will be refracted if that is a transparent medium. And in case of when the light is according to the Malus, when the light is incident on the glass slab, the light is reflected light is partially polarized. He observed that, Malus observed that. After the Brewster, the scientist Brewster forwarded that his study and found that when the light is incident on the glass slab, some of the light is reflected and some of the light is refracted. When the natural light of incident on the glass slab, the reflected light is partially polarized. After this, when the light is incident on the glass slab, it is certain angle that is called as a polarized angle. It is certain angle called polarized angle. The reflected light becomes linearly polarized. Here is the eye, which we can see. This is linearly polarized when the reflected ray, this is reflected, this is refracted. So when the reflected and refracted rays having the perpendicular to each other, means when the unpolarized light is incident on the glass slab of a certain angle is called polarized angle. The light, some of the light is reflected light is linearly polarized. Linearly polarized when the angle between the reflected and refracted light will be perpendicular to each other, means 90 degrees to each other. Then this happens when only, means this is totally linearly polarized, means reflected ray linearly polarized when both are having perpendicular to each other. Reflected and refracted waves are each other, then only the reflected ray polarized, linearly polarized. So that here is that the incident angle, this is the unpolarized light is incident on the glass slab, which is making an angle IPB the incident angle. The angle of incidence is IP, and with that angle some of the refracted, the actual path is this one, and refracted angle is R, and some reflected angle of incidence is equal to angle of reflection. So that's why IP, both are the IP, and both are, whenever the both are perpendicular to each other, then only this linearly polarized, the light will be linearly polarized. But we know that then here the reflected ray, that is R plus 90 degrees, which is equal to R plus IP, that is equal to 90 degrees. R plus IP is equal to 90 degrees, means here it is, which is having that this one is the R plus 90 is equal to the 99, R plus incident angle is equal to 90 degrees. Then Here it is that the refracted angle R is equal to 90 minus IP. 90 minus IP. But we know that from Snell's law, from Snell's law, that is refractive index mu is equal to sine of incidence angle by sine of refracted angle. So from this relation we are substituting the equations, then we can get that mu is equal to sine I. Sine I means we have that the I means incident of angle is IP, so that's why sine IP by sine R. Sine R means we have that 90 minus IP. From equation number 1 considered, from 90 minus IP from equation number 1. Then we know that sine of 90 minus theta is equal to cos theta. So that's why we are writing that sine of 90 minus IP is equal to cos IP. So from this we can write that mu is equal to sine IP by cos IP. IP means the polarized angle, the angle of incidence. So polarized angle. So that's why from this relation we can write that tan IP, sin IP by cos sin theta by cos theta is equal to tan theta. So that's why we can write that mu is equal to tan IP. This is called Brewster's law. Brewster's law. This is called Brewster. Mu is equal to tan IP means that is called as Brewster's law. Once again, when the unpolarized light is incident on the glass slab, some of the light is partial, some of the light is reflected, some of the light will be refracted. So here it is that when the light is polarized, when the light is incident with the angle, with the certain angle is called as polarized angle, then the reflected light linearly polarized. When the refracted and reflected lights are perpendicular to each other, then only the reflected light are linearly polarized. So that's why here, according to the Brewster, the angle of incidence will be polarized angle, that is IP, and the angle of refraction will be small r. So from that equation we can write that small r plus IP is equal to 90 degrees. Small r plus IP is equal to 90 degrees. So that's why R is equal to 90 minus IP means refractor is equal to 90 minus IP, angle of refraction. Then from that mu is equal to sin I by sin R. Mu is equal to sin I by sin R from the Snell's law. So here it is that mu is equal to sin I means I, we know that angle of incidence means polarized angle, that is IP, sin IP by sin of 90 minus IP. From that relation we can write that by measuring that sin of 90 minus theta is equal to cos theta. Sin theta by cos theta is equal to tan theta, means theta, in this theta we have IP, means polarized angle. So that's why mu is equal to tan IP is called Brewster's angle. For a normal glass, we can calculate that the refractive index of the glass will be mu is equal to 1.5, means mu is equal to 1.5 for a normal glass. For normal glass, refractive index will be mu is equal to 1.5. 1.5 is equal to tan IP, means here it is that IP is equal to tan inverse of 1.5. The value will be 57 degrees, means angle of incidence will be 57 degrees. Whenever the IP is equal to, for normal glass, refractive index of 1.5, which is having that whenever the light is incident on the normal glass with an angle of incidence will be 57 degrees, the reflected light linearly polarized. This is about polarization by reflection according to Brewster's law. Brewster's law will be mu is equal to tan IP.